You think the speed of light is just a number, 299,792,458 meters per second. Fast. Really fast. The fastest thing we know. Fine. But why is it the limit? Why can't you go faster? What actually stops you? Most people never really think about this. They just accept it. Einstein said so. Speed of light is the cosmic speed limit. But that's not an answer. That's just repeating words. When you really ask why nothing can go faster than light, when you dig into what's actually stopping you, you discover something so strange, so different from everyday experience, that it completely changes how you think about space and time. The speed of light isn't just a speed. It's not just the fastest thing. It's the structure of the universe itself. It's woven into the fabric of space and time in a way that makes going faster literally meaningless. Let me show you what I mean. Let's start with something simple, something everyone knows. Things fall. Drop something, falls down. Galileo measured that objects fall about 16 feet in the first second. Drop a ball, drop a rock. In 1 second, it falls 16 feet. Now think about the moon. The moon goes around the Earth. It doesn't fall straight down. It stays up there, orbiting. But is it really not falling? If the moon were just sitting still in space, gravity would pull it straight toward Earth. It would fall. But the moon is moving sideways. And while gravity pulls it inward, it keeps missing the Earth. That's what an orbit is. Continuous falling while moving sideways fast enough to keep missing. Newton had a brilliant insight. The moon is about 240,000 miles from Earth's center. We are about 4,000 miles from Earth's center. So the moon is about 60 times farther away. Newton asked, what if gravity gets weaker with distance? What if it follows an inverse square law? If you go twice as far, gravity becomes 4 times weaker. 3 times as far, 9 times weaker. At 60 times farther, gravity should be 60 squared times weaker. That's 3,600 times weaker. On Earth, things fall 16 feet in 1 second. So at the moon's distance, things should fall. 16 feet divided by 3,600, that's about 1/12 of an inch per second squared. And when Newton did the full calculation, the moon fell exactly the amount his law predicted. This was huge. Newton connected how fast things fall on Earth to how the moon moves in space. 2 completely different facts. With one single law, there was no going back. He went further. He calculated that planets should move in ellipses. And they do. He explained tides. Why there are 2 tides per day. Why Earth is round. Why it bulges slightly at the equator. Everything fell into place. But as measurements became more precise, something strange appeared. The moons of Jupiter sometimes arrived early, sometimes late, by as much as 8 minutes. That was enormous. Then it was noticed they were early when Jupiter was closer to Earth, and late when Jupiter was farther away. Ole Romer realized what was happening. Light takes time to travel. We don't see things as they are now. We see them as they were when the light left them. By measuring these delays, Romer calculated the speed of light. This was the first proof that light is not instantaneous. Once we knew the speed of light, something very strange became obvious. Light always travels at the same speed, no matter who measures it. No matter how fast you're moving, you stand still. Shine a flashlight. You measure 299,792,458 m/s. You get on a fast train. Half the speed of light. You shine the flashlight forward. Common sense says the speed should add, but they don't. You still measure the same speed. You go faster. 90% the speed of light, still the same. 99.9999%, still the same. The speed of light does not add. This should break your brain. Einstein realized the answer. Space and time are not fixed. They are flexible. They stretch and bend to keep the speed of light constant. When you move faster, time slows down. Your clock ticks slower. Distances contract. Space compresses. These effects are real. Measured. Tested. As you approach the speed of light, your inertia increases. To reach the speed of light would require infinite energy. That's why nothing with mass can reach it. Light can, because photons have no mass. But the real reason is deeper. The speed of light is not imposed on the universe. It is a consequence of how space-time is structured. Space and time are woven together. And space-time has a geometry. That geometry has a built-in conversion factor between space and time. That factor is the speed of light. It's the maximum rate at which cause and effect can propagate. If you could move at the speed of light, you would have no motion left for time. Time would stop. That's why light doesn't experience time. You can't go faster than light, because you can't have less than zero motion through time. This isn't theory. Particle accelerators confirm it. GPS satellites require it. Cosmic ray muons prove it. If relativity were wrong, GPS would fail within a day. So why is the speed of light the limit? Because space-time has a maximum rate of change, a maximum speed of information, a maximum speed of causality. That speed is the speed of light. It's not just a number. It's the key. The thing that unlocks how space and time work, and the fact that we can understand it. measure it, test it. That's the beauty of physics. Not comfort, not simplicity, truth.